There we go. Here's how important elimination is. Next week, so far we've had to solve for an x and a y, and we've had two equations. Next week we're going to have an x, a y, and a z, and you're going to have three equations. You guys can go. Just make sure to watch this video sometime. Yes, good luck.
Good luck, guys.
Nebraska City? I think that's where they're going.
Meet the pioneers.
Okay.
You sure this is 3.2?
Yeah, it's the same section as substitution. I just teach them in 2 different days. So we don't have a lot of information in one day. So elimination is exactly what it says. You're going to try to eliminate a variable. So for our first example, we'll start with a real easy one. If I have 4x plus 2y, already forgot, equals 9. And then negative 4x plus 3y equals 16. Here are my two equations. First of all, if I said you're going to solve this using substitution, why is this difficult?
Because you have to do a lot of work to get into the variables.
Right. If I was to choose this x to solve for, I would have a fraction because I'm going to have to divide by -4. And there's no variable that it's easy to get by itself. So this is where elimination comes in, and this is why you use elimination, especially when we have 3 variables that we'll have next week. Elimination, another title for elimination is called combinations. Some books call it combinations. And basically what that means is, they're both right, because you're going to combine the 2 equations, and your goal is to eliminate one of the variables. So when I combine together, meaning I add together, what happens with my 2 x's here? They eliminate, because I've got a positive 4x and a negative 4x. So they eliminate, which is what my whole goal was. And then I just add straight down. So I have a 5y equals 25. Yeah, you have. So you divide by 5, y is equal to 5. So there's half of your answer right there. Now here's the part of elimination that's not as easy as substitution. When we did that last problem and we plugged in, we had the x already by itself, and it was easy to solve for the second one. This one you're just going to have to do a little more work because these aren't solved for. So we can choose either 1 or 2. I would probably choose 1 because it doesn't have a negative in front of it. But you're going to plug 5 into this y here. So I would have 4x plus 2 times 5 equals 9. So I have 4x plus 10 equals 9. So I have 4x equals -1. And then I need to divide by 4. And I get x is equal to -1/4. A gift. I love gifts. Love them.
Some leadership.
Oh my gosh, this is the best gift ever. Thanks, guys.
You're so welcome.
Thanks so much. You can interrupt to bring me gifts every day.
She's recording voice.
Yeah.
Sorry, you guys can listen to our beautiful voices on the recording.
Yes, you'll be on there now. Now you're famous. Okay, so here are my 2 points, or my 1 point, that if I were to graph these two, it would intersect at the point -1/4 and 5. Easy enough? Okay, let's math it up a little bit. Just a little bit. It's not terrible. But now notice with these two that I give you. 2x plus 7y equals 4. And 3x plus 5y equals -5. What do you notice will not happen when I combine the 2 together? Nothing's going to eliminate. So we have to manipulate this one a little bit to make it so that something will eliminate. So the first thing you have to ask yourself, and it doesn't matter if it's x or y, sometimes there's one that's easier than the other one to eliminate. In this case, they're equally not easy, or easy. They're easy, but there's nothing that's easier. So as a class, we have to decide, do we want to eliminate the x's or do we want to eliminate the y's?
Wise.
Y's? Okay. So what can I get y's, these two numbers both to? It's kind of like thinking of common denominators. 35. Okay? To get these to 35, what do I need to multiply this 7 by to get it to 35? 5. So I have to multiply this whole top part by 5. Not just part of it. It's got to be the whole thing because you can't take a part of it in an equation and change it. You have to change all of it. Okay? What will I need to multiply this bottom one by? Okay, but before I had a 4 and a negative 4. So I don't need a 35 and a 35. I need a 35 and a negative 35. So what am I going to? Negative 7. You got to make sure one of them is negative. Now, sometimes you'll see that it's already set up as a negative and a positive. Those are the ones you want to eliminate. But let's go ahead and distribute to everything.
Oh, yeah.
So I have 10x plus 35y is equal to 20. And then for my next one, I have negative 21x minus 35y equals 35. Everybody agree with that?
Yep. Yeah, I agree.
Okay, now we can combine together. When we combine, we're adding. So here I'd get negative 11x equals 55. Divide by negative 11, and you get x is equal to negative 5. Okay? Everybody good with that? Okay, now here's your choice. You have 4 choices. You've got equation 1, equation 2, equation 3, and equation 4 to choose from. All of them will work. I tend to not use 3 and 4. Why? Because they're bigger numbers, okay? They're doable. You can do that. You're all capable of multiplying bigger numbers, especially if I give you a calculator. But I always seem to go back to the original ones. But you are welcome to whichever one you want. I'm going to choose number 1. So I have 2 times negative 5 plus 7y equals 4. So I have a negative 10 plus 7y equals 4. Add my 10. Add 10, so I have 7y equals 14, so y is equal to 2. So if I were to graph these 2 equations, it would intersect at the point negative 5, comma 2. Okay? I'm going to give you guys one to do from start to finish on your own, and then I'm going to show you the special cases, and then you have work time. It's in the book, but I only have a handful of problems, and they're pretty easy.
Is this like 3 questions?
No, more than that.
It is
Bigger
this
hand.
one easy.
Okay, so here I have 3x plus 7y equals 15. And then I have 5x plus 2y equals negative 4. Let me make sure I wrote that down right. Yes, I did. Okay, let's decide. I'm going to have you do this from start to finish, but so our notes are the same. Let's decide, do we want to eliminate x's or y's? X's? Okay. You guys eliminate the x's. What number are you going to get these x's to? 15. Okay. One of them needs to be negative. So you guys start and finish this, and then we'll compare.